So we're going to continue with polynomial identities. If you remember from the last video, we went over 4 polynomial identities. Difference of squares, sum of squares, difference of cubes, and sum of cubes. Okay? Now, what I want you to really remember is that even though we can use those identities for multiplication, we really just need them for factoring. So today, we're going to go over 2 more factoring techniques. So the question of the day, what are the other ways of factoring? So we have factoring by grouping and we have factoring using U substitution. Let's go over factoring by grouping. Now, there's a few things that I want you to look into to be able to see which one is or when should you use factoring by grouping. So the 2 conditions that you need to have in order for you to do factoring by grouping is you gotta have 4 terms. The second one is make sure that you check for a greatest common factor, and you should always be doing that regardless. Okay, so those are the 2 conditions that you need to look for when you're dealing with factoring by grouping. So in this case, our polynomial does have 4 terms. We do not have a greatest common factor in this case, so we can go ahead and get started. So we're actually going to be using the box method. Now, the only difference is going to be that we're going to be using the box method backwards. So in a box, we have 4 different spaces, which is why one of the conditions to be able to use factoring by grouping is having 4 different terms. Now, instead of looking for the inside numbers, we're actually going to be looking for the outside numbers. So I'm going to go ahead and place my 4 terms inside my box. Okay, so again, I'm going to be looking for the outside numbers. Now, how are we going to be finding that? We're actually going to be finding the greatest common factor of 2 boxes at a time. So I'm going to just number them 1, 2, 3, and 4, and I'm going to be taking the greatest common factor out of 1 and 2. Now, if I look at 1 and 2, I can see that they both have 4 x's in common. They don't have a coefficient in common, but they do have 4 x's in common, which means that I can actually take out 4 x's out of each one. So the greatest common factor out of those 2 would be x to the power 4. Then I'm going to do 3 and 4. So I'm going to take the greatest common factor out of those 2. I can see that they both have in common a -9, and they do not have any x's in common. So I'm done right there. Now I'm going to do 1 and 3. For 1 and 3, same thing. I see that they have 2 x's in common, and that is about it. So my greatest common factor is going to be x squared. And the last one is going to be 2 and 4, so I can see that they have a 2 in common and no x's in common. So that would be it. I'm going to go ahead and check my answer real quick. All right. Now, how can I check my answers? Well, check the multiplication. X squared times x squared, x to the power 4 times x squared equals x to the power 6. So it works. 2 times x to the power 4 equals 2x to the power 4, which matches my answer, so it works. And then I have -9 times x squared, which equals -9x to the power 2, so it works. And the last one would be -9 times 2, which equals -18, which it works. So everything's working out perfectly, which means that my answer is going to be the 2 factors that I just found, which are x to the power of 4 minus 9 and x to the power of 2 plus 2. So far, I have factored my polynomial expression. Now, the one thing that makes this type of problems more difficult is that at some point, you can actually continue to factor any one of those 2 factors. So, for example, let's take a look at my answers. I have x to the power of 4 minus 9, and I have x squared plus 2. The question is, can I continue to factor any of those two? The answer is yes. If you look at the first factor, I have a perfect square, and I have a perfect square, and I have a minus, which means that this problem is actually a difference of squares. Which means that I could continue factoring this expression. Now, if I follow the formula for difference of squares, I know that this is A and this is B, and that my answer should look like two parentheses. One is going to be a plus, one of them is going to be a minus. Now, to find A and B, if you remember from the last video, all we need to do is take the square root of each one, and that should be A and that should be B. The square root of x to the power of 4 would be x squared, which means that both are going to have an x squared. The square root of 9 is going to be 3, which means that both are going to have a 3. And I'm just going to go ahead and bring down the other factor. So at this point, I can go ahead and check again if I can simplify something. And in this case, there's nothing else that you can simplify, so that would be your answer. Okay, so the one thing that you got to watch out for is just be careful and always double check if you can factor further. Now, in terms of factoring using U substitution, so the key concept when it comes to using U substitution is that at some point you're going to be working with polynomials that have degrees higher than 3, so 4, 5, 6, 7, 8, and at some point you can't really use any of the factoring methods. So how do we deal with this? Well, we can actually let U substitute an x squared. So we can let U be equivalent to x to the power of 2. Now, why do we want to do that? Because we want to rewrite the problem in a way that we can actually factor it using one of the methods that we know. Now, for example, this one. This problem looks very familiar. It looks like 8x squared plus bx plus c. It looks like a quadratic function. And if you remember, how do we factor quadratic functions? Well, we use the emoji method. We use the x method, right? However, we can't use the emoji method because this is a quadratic function, which means that the degree is 2, and this is a degree 4, which means that this is not a quadratic function. So we can't really use the emoji method. But what if there was a way to rewrite it so it does look like a quadratic function? Well, let's try U substitution. I'm going to let U equals x squared, which means that for every x squared, I'm going to replace it with the U. Well, if I rewrite this, I'm going to be left with 2x to the power of 4. Well, how many u's can you fit in x to the power of 4? Well, I can fit 2 of them, which means that I can replace x to the power of 4 as u to the power of 2. Plus 5x to the power of 2. Remember that I can replace x to the power of 2 with 1u. So in this case, I'm going to have 1u. And then minus 3. So what I did was I basically rewrote the whole problem in terms of u. So now I have a quadratic function because the degree is a 2. And now I can go ahead and do the emoji method. So my first step, I'm going to go ahead and multiply my a times c, which in this case is going to be 2 times negative 3, which is negative 6. I'm going to bring down my b value, which is 5. And now I'm looking for two numbers that multiply to negative 6 and add up to 5, which in this case is going to be 6 and 1. And the 1 is going to be negative. Now, don't forget that we got to divide it by our a value. So we're going to divide both of them by 2. Cool. Once that's done, let's put them into factors. Now, remember that we changed the x in terms of u, so we got to use u's. And let's just simplify it. 6 divided by 2 equals 3. So I'm going to be left with u plus 3. Now notice that the second term, the second factor, is gonna be simplified to a decimal. We do not like decimals. So if you remember the shortcut, we're actually going to take the denominator, put it in front of u, and just rewrite the factor like that. So I'm going to have 2u minus 1. All right. So we're done. Almost done. I was able to factor my expression. Now remember that we actually started with an x and we ended with a u. Well, our answer should be in terms of x because that's what we started with. So I'm gonna have to go ahead and replace my u back in terms of x's because I want my answer to be in terms of x's, not u's. So for every u that you see is now going to be an x squared. So let's go ahead and rewrite this. So that's u plus 3, which is now going to be x squared plus 3. And the second one is 2u minus 1, which is now going to be 2x squared minus 1. So again, can you simplify further? The answer in this case would be no. There's nothing else you can factor, so that would be your answer. So those are the new factoring techniques that you have. So now you have 4 identities plus 2 more.